Hello, I'm Anna Mackay, and today we're looking at rational indices. Rational in this sense, fractional powers. So you're probably familiar with this law here, that if something is to the power of a half, that's the same as the square root of that base. Just unpacking that a little bit, if we look at it in terms of a to the power of half multiplied by a to the power of a half, the laws that you know are that if it's the same base, you add the powers. So we could rewrite it like this. And that's equivalent to a is equal to 1 or just a. So same with the square roots. It's the square root of a multiplied by the square root of a gives us just a. So as we know, a half is the equivalent of the square root sign. We're going to look at where that number of 2 comes from. We're going to look at thirds and other numbers. So the next rule therefore is if it's a to the power of a third, that can be written as the cubed root of a. So notice that there's now a little 3 out the front of the square root. When we have a half, we don't write the little 2 there. You could. It's the same idea as, if you had 2x, you write the 2. But if you just had x, you don't have to write it as 1x. It's just mathematical convention that you don't put the 1 there. We just all know it's a 1. It's the same here with the to the power of a half. We don't have to put a number 2 here. You can if you want to, but it's just understood. So the general rule for this is anything to the 1 on nth power is the nth root of a. For n belonging to this z here, which is German, I believe, for Zahlen, which means numbers. So where n is a number and it's a positive number as well. Right, and summarizing that, so you notice where the n and the m are. Up here with the third, that's the cubed root, so the 3 goes out the front of the square root, and the 1, well, you technically can't see, but the 1 is actually within the a there, so it could be written as this. That is the same as a to the power of a third. So generalizing that rule here, the denominator is the number out the front of the square root, and the numerator is within the square root with that base. And this is for all a greater than 0, where n is a positive integer and m is an integer. All right, some examples. We're asked to write as a single power of 2. So using what we've learnt there, we can recognize that as the cubed root of 2. So that is the equivalent of 2 to the power of 1/3. Simple one. Next, 1 over the square root of 2. First of all, thinking about the square root of 2 is 2 to the power of a half, but we don't want to leave that as the power of 2 on the base in the denominator. We have to bring that up, and to do that, you make that power negative. So that's a single power of 2. This one here, you might ask yourself, it's a 4, not a 2. You need to be able to recognize powers quite quickly. And so you'd recognize that 4 is 2 squared, but let's just do one thing at a time. Let's look at it as the 5th root of 4, first of all, and then we're going to write that as 2 squared to the 5th. And then our index laws tell us that we multiply those numbers together. You're multiplying the numerators essentially, so it's 2 to the power of 2/5. It's not, in case you're tempted, 2 to the power of 2 to the power of a 5th. That's not correct. They're sort of on the same level, if you like, the 2 and the 5th. Using our calculator to evaluate these, so not too much to unpack there. So you put in 2 and then to the power, and then I would suggest using the fraction button and inserting the 2, the 7 and the 5 to get this, and writing that to 6 decimal places it's asking. So let's have a look here. We've got 1, 2, 3, 4, 5, 6. We're ending at the 5, so we have to look at the 1 after that, the 8, and yes, it rounds it up. So therefore, 2 to the power of 7 on 5 is approximately equal to, or you could do your approximately equal to as squiggly equals 2.639016. That's the answer for that. And the next one, 1 over the cubed root of 4. So the way you type that in is I would do a fraction, and then there was a button on my calculator that looks approximately like that. Choose that one. You might have a button that's already got the 3 on it, but the thing is that'll work for the cube root, but what about the 5th root? So that's the button that'll be handy. Substitute your numbers in, and again 6 decimal places. 1, 2, 3, 4, 5, 6. Chop it off and have a look at the 6th one. That's a 5, so we do have to round. So therefore the 1 divided by the cube root of 4 is equivalent to, approximately equal to 6.29961. Because we had to round, that's why we put approximately equal to. And without using our calculator now, write in simplest rational form. So you need to be able to recognize, as I said, some numbers. So 2, the powers of 2, 2 squared, 2 cubed, those sorts of things. And same with here, that'll be something to do with base 3. So my first advice is to write that 8 as 2 cubed, and then we'll worry about the power in a minute. So that's our first step. And then you are going to expand the brackets here. So you're multiplying the numerators, because technically 3 is 3 over 1. And then we're multiplying that by 4 over 3. So we're going to get 2 to the power of 12 on 3, which is equivalent to 2 to the power of 4. Now, you might be tempted to leave it like that, but it said simplest rational form. What would be the name of the form that is currently in right now? Index form. And so it didn't ask for it in that, so it wanted simplest rational form. So just working out the number, if there's one to work out. And this one over here, the first step I would do is to put it into base 3, and then we're going to work out the rest of the power. So you're going to multiply here. You can jump straight to it's simplified if you like, if you know how to do that, but I'm just going to show each step. We're multiplying that 3 by the numerator of 2, so we're getting 3 to the power of negative 6 on 3. That comes out to be negative 2. Don't leave it there, we need to simplify that. That's 1 on 3 squared, or 1 on 9. So that's simplest rational form. Okay. Thanks for joining me. Subscribe to the channel if you haven't already, and the next video in this series is algebraic expansion and factorization. Thank you.